Okay. At the same day, new problem. Let's do this lovely medium. A Sudoku solver. Determine if 9 by 9 Sudoku. But there's no way. This is a fucking medium. This is like an extra hard. This is some old bullshit right here. I don't want to do this. Okay. Let's see. 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the... Okay. Never mind. Maybe that is a medium. Each row is contained blah blah blah. Blah blah. It's 3 by 3 sub boxes. Blah 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 blah. Partially filled is valid, but not necessarily solvable. Okay. So it's not okay. So it doesn't have to be necessarily solved. Yes. All right. That is actually pretty easy. It's actually pretty easy. I think. I don't know. Maybe I'm wrong, but we'll see. I mean, there's probably a bunch of really clever solutions to this, but like the brute force solution just seems super trivial, right? You're just looping through the row and seeing if you have any duplicates. Okay, so in terms of checking for duplicates, what's the cleverest way to do this? Gosh, I like, since you only have the digits 1 through 9, I like this. I like checker. Is it Boolean? Why does every language do this different? Right, so it's 9. Yeah, okay. So all of these are false by default. And then as you loop through a row or column, you set the digit that you find to true. If you encounter another digit and that spot is already true, then you have failed, right? So that lets you check the digit without having stored the digits. You just have this array that tells you whether or not you've seen a digit yet or not. So let's try that. Let's just check rows first. There's probably a smarter way to do this, but let's just do this the easiest way possible. So let's for int I equals 0, I is less than board.length I plus plus, and then for int k equals 0, some people use I and j. Those people need to be killed. All of them. Every single one. And no mercy to their ancestors. I and J are so similar. I can't tell you how many times that's fucked me up. In somebody else's code base because I decided to do that. Luckily now everybody just does like reduce operators and streams and lambdas, and I can't read anything anyway. So I'm kidding. But I'm not entirely kidding because stream operators are they started to grow on me less and less and less. Okay, and so this is gonna be checker dots. What is there like a clear? Binary search, because there's probably like a clear that's advantageous, right? Like it's just more efficient than looping through yourself. I have to think that there's one, right? Like a default, maybe? Surprising. Right. Yeah. I'll just do that there, just in case. I don't even think I have to, but just in case. Just in case they don't default to false, who knows? Alright. If, and then what is that? Board of I of k is not equal to, and then what is it? What's the character for a missing spot? A dot? Is it a dot or a comma? It's like a dot. I want to say it's a dot. Okay. And, annoying that they used character instead of integer. Seems unnecessary. Could have just used -1 for nothing being present there. Feel like that would have been easier. Well, actually, char takes less space, maybe. It's good. Maybe I'm wrong. It's good programming there. All right. Anyway, so I want the int value integer dot value of, and then, well, let's just save board of IFK. So that I don't have to keep referring to it that way. Now, is there a value of char? There should be. Returns integer representing a specific int value. New integer instance is not required. This method should be generally used in preference to the constructor, as this method is likely to yield significantly better space performance. Okay. We'll always cache values. Yes, good. Yeah, that's what I want. Yeah, I thought so. I thought you could quickly convert char to int without much loss, but let's see. Okay, so I am getting the value of these spots, and then I'm going to set checker of value equals true. However, if checker of value, well, it's Boolean, so I don't need to do that. Then it's, I've already seen that int before. Otherwise, we just set the spot. So we've already seen this number, and then this is we have not seen this number. We've already seen this number. We have not seen this number. Okay, lovely. Lovely, lovely, lovely. Okay, so that's the rows, and now I want to do the columns, but should I check my work so far? Make sure it runs at least? It's probably a good idea. That did not paste well. Yeah, see, it's out of bounds. Value of spot was not giving me what I expected. Let's see what it thinks the spot is. Somehow missed the S there. Yeah. So 5 gives me a value of 55. Man, that sucks. Alright, so then I can do a new integer. Oh, you can't. Deprecated. That's not done. I mean, I could do a quick lookup table. Quick lookup, it's only 9 values, so that could do the trick. That's the fastest way to convert char to int, because this is going to happen a lot, so it's important for the performance considerations. There's no from char. Yeah, alright, let's try parseInt, I guess. Just because there's a parseInt char sequence that could be working better. I thought parseInt wasn't very performant. Plus I need this awkward string conversion. Although I could probably just cast, since it's a single character. I'm not sure if Java lets me do that, but no. sucks. Yeah, I definitely don't want to do a string conversion, a char to string conversion. So what's the fastest way to go char to int? It's also kind of weird that in the example they show them in double parens for each char, so. Maybe I'm spending too much time thinking about this. It's not really a huge performance consideration. But on the other hand, it does happen like 1,000 million times over the course of this algorithm, right? So it is kind of important. Maybe I should just go through once and map the array into ints to make this easier. Kind of cache the values. That would probably be the fastest way to do it. Yeah, could probably work. So what's the fastest way to go from a string? It's probably just to concat them, which sucks. Let's see, now I can't do like an equality check. Yeah, bummer. Alright. Alright, we'll do that then. We'll do a quick string concat, and I'll figure out something better for that later. Yeah, I don't like it, but it is what it is. Index 9 had about, right? It's actually the digits 1 through 9. Oh, 1 through 9, but there's no 0, so yeah, I'm not gonna shift by 1, so that's way too annoying, so I'll just have the 0th spot unused. That's fine. So, okay. That should do the trick then for the rows. Yep, lovely. And then I'm gonna want to do the columns. So then the old columnars. Alright, how do I want to do the columns? So do I want to go... I want to say I just do this. Yep, just do that, and then I'm tracking down. Yep, that should do the trick. Should do the trick. Okay, so that should check the rows, that should check the columns. Now I want to check those cells, so that's annoying. There are 9 of them, and they each follow their own little rule. You go 3, 3, and 3, so that they're all 3 by 3, and then you would hopefully move on to the next one. So check cells. So here I've got for int cell equals 0. What do I want to do? Do I want to track maybe the top left corner of the cell and then just advance when we're done? That seems reasonable. Yeah. Yeah, so, well. It's annoying to have to track the top left corner of each of those little subcells. It would be more annoying for me to have to specify. Yeah, I think this is probably the easiest way. And There are definitely 9 of them, so the 0 through 9 should get the trick done. Alright, so when we start from the first one, we're going to have int cell x is 0, int cell y is 0. Okay, and then we're going to start our internal loop. So this one starts at the beginning of let's not flip these just because that's confusing. And so we start at cell x. This one starts at cell y. So these are the x and y respectively. And then we want to advance until 3 onwards. Yeah, three spots onwards in both directions. So it's cell x plus 3 and cell y plus 3 respectively. And then that gets, yes, Bob's your uncle. Okay, now we just need to advance these cells, and then you actually only erase at the end of the cell. Okay, so this would be the end of cell. Right, so we are starting at the top left corner, moving 3 spots. Yes, so the next 2 spots, and then we go down respectively. And we stop if we've seen the number before, obviously, and then when we get to the end of the cell, we reset our checker array, and we also want to move to the next corner, end of cell, advance to next cell, and reset. So this is going to be cell x plus equals 3, so yeah, 0, 1, 2, 3, 4 will be that spot, for example. And if cell x is greater than board dot length, yes, so if cell x is greater than board dot length, then the cell x equals 0 and cell y plus equals 3 instead. So that means once we get to here, it's going to try to advance 3 spots. That puts us in the ether. It'll reset to 0 and move up there. Okay. So seems solid, even though it's definitely not O of n in the slightest. Check that out. So out of bounds there. In my cell hacking 1. Okay, so less than cell y plus 3, blah, blah, blah. Then these are both inside. Right, okay, and which one's out of bounds? Let's see. It might be plus 2 instead of 3. For some reason, I'm thinking it's 2. Okay, so it's the end of cell 0. So it goes 0, 1, 2, right, and then row 0, 1, 2, right, and then it's going to be, oh. Why would it attempt row 9? In cell 3, it starts at row 9. Oh. Greater than or equal to. Because this one spot out here is the length. Yep. Yeah. All right. Then we don't need the print statement, and that should do the trick. I don't want to write test cases for this one for pretty obvious reasons. Why did I just try to save the page? Okay, just run that one more time, make sure I didn't delete anything. I tried to remove the print statement, and it seems good, if not very efficient. Oh, wow. It's actually good and efficient. Well, this was hardly a medium. I mean, this was easy as dog shit. I think I did this one faster than I did the stupid binary search one. Well, this one's really just tedious more than it is anything else. I guess checking the cells is a little bit complicated, but years of working with Java Swing prepared me for this moment, so I was ready to go. My score is not great, and I'm sure that's 100% because I couldn't figure out how to parse them correctly. Let's see if I cache the values, if I can do better. So int board equals new int. Yeah, this is unlikely to work. It's a whole extra double loop, and yeah, there just needs to be a better way to read chars into int in Java. Let's see. If I just cast it, character get numeric value. That's what I'm seeing on the Googs. Let's try that. Let's see if that's faster. I can replace it in 3 places. I'm not that lazy. Much better. Look at that. Look at that. We went from 6865 to 8678, right? I mean, that's just from taking a different function from the standard library. See, I knew parse int was going to be slow, right? But I also don't have to prefill. But I didn't know how slow it was going to be. I could probably optimize my checker a little bit better too. It might be... Nah, you gotta fill it every time. I mean, I could just fill... Fill might be less efficient than me actually for looping it through. Right? Because nah, probably not. It's probably just a for loop under the hood that does the same thing. So I think I've probably eked as much efficiency out of this approach as I can. Let's see what getting rid of that one fill at the start brings me to. Actually dropped my score. So that's funny. It dropped it from the cache or something. What gives? I want my other score back. The memory stuff is so small. A few kilobyte difference. It's probably like more up to noise than anything else. All right, I'm interested. Is there a smart solution to this? Because I don't think so. Alright, so a lot of people spun up a hash set, which is basically what I used my checker for. It's a hash set. The problem with the hash set versus the okay, I get, a hash set's obviously an existence checker, but checking a hash set is not nearly as fast as accessing an index. So when you have numeric information, the index-based solution that I've got is going to be much faster. So the hash set is kind of the mistake here, because it's got the overhead head of the hashing algorithm to work with. Okay. This doesn't seem... Oh, that's so clever. So clever. Okay. Yeah. That's... Okay. I mean, that's too clever by far. Checking all three at the same time within the same loop. Oh, but speaking of checking them in the same loop, I mean, I could have two checkers running concurrently on row and column. Could have done that. See? That would have been good. But this, having this running concurrently with the other two checkers, boy, that's a lot. That's a lot to ask for. That's a lot of cognitive burdens. This, like, divide by 3 shit here, that's tough to think of. But yes, technically you can get the spot in each cell by doing, but yeah, that does get you the spot in each cell. So what they're doing here is checking checking the row, column, and cell in the same loop. Yeah, yeah. Very smart. Very smart. In this case, you do need the hash set, although you could have gotten away with the Boolean array as long as it's big enough. So in this case, it's going to need to be like what, 9 by 9. You need to encode all the spots. So it would be 9 by 9 by 3. So it'd be quite large. That's actually might still beat the hash set. Yeah. It's clever. It's very clever. Okay. Well, I like my solution too. It's not quite as smart, but it was quick. Thanks for tuning in. See you next time.